notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, sections 1, 2, and 3. All 51 of these videos have been published on YouTube in their entirety. Section 4, measurement. All 17 of these videos are completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 of these videos are completed. 5 have been published in their entirety on YouTube. We are now at Algebra section 6. This is the 14th of 22 videos in this section, and hopefully by mid-September this section would be finished. Then section 7, relations, functions, and graphs, by October 2025, to be followed by geometry and trigonometry, to be completed somewhere in November 2025. And finally, section 9, vectors and matrices, to be completed by the end of this year, 2025. Disclaimer down here, this schedule is just a projection and is not to be interpreted as a contract with anybody. As I just pointed out, section 1, number theory and computation, has 33 videos, and those 33 videos are all published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So please make sure you look at these 33 videos and know them very well. A reminder here, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. From section 2, consumer arithmetic, as I just said, all 12 of these videos have been published on YouTube in their entirety. Section 3, sets, all 6 of these videos have been published on YouTube in their entirety. Section 4, measurement. Out of these 17 videos, these indicated in yellow here have been published on YouTube in their entirety, and these others are only partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, statistics, 18 videos. Again, these 5 indicated in yellow here have been published on YouTube in their entirety, and these others are only partially published on YouTube. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. And we are now at section 6, algebra, which is made up of 22 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get more practice questions. CSEC recommends the following, shown at right. These here. From those, please pay close attention to these last 2 down here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course, with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, I think, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. You can navigate by topics or years where all questions for the past several years have been worked out for you. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely it will be explained. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like, which is this here. You will have to first register and then sign in. That is the URL again up there. This URL will be in the description of this video below so that you can easily click on it and be redirected to this website. This is a formula sheet that is provided for CSEC math examination papers. This sheet that you see here on the left. There will be a link in the description below where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little closer, and we will take a closer look at it later on in this video. Please note that you do not need to learn these formulae on this formula sheet, as this sheet will be provided during the examination. And this is the below part of the same formula sheet. And while you do not need to memorize these formulae, you do need to know when and how to use them. Overview of Section 6 Algebra. Objectives 1 to 4 have been completed in these first 4 videos. More overview. Objectives 5 to 7 have been completed in these 3 videos. Continuing with overview, objectives 8 to have been completed in these 4 more videos over here. Continuing with overview, objectives 12 and 13 have been completed, 12 and 13. So we are now at objective 14. As you could see, this objective has been split in 2 parts. We are now dealing with part 1 in video 14. Factorize algebraic expressions. And then we still have to go up to objective 21 to complete section 6, algebra. And that will be done in these last 5 videos here. Takes us to video 22 from 21 objectives. So as I said, I have completed 13 videos in this section, which takes us up to objective 13. We are now at objective 14, split in 2 videos. This is part 1, video 14. These objectives up here and videos based on them have been published in their entirety as indicated, and these others are only partially published on YouTube. Video 14, when this is finished, it will be published in its entirety. Factorize algebraic expressions. So as I said, we are here, objective 14, factorize algebraic expressions. And we do have some content, the 4 types of algebraic expressions that you are required to know for CXC or CSEC, how to factorize them. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So objective 14, section 6, factorize algebraic expressions. And these are the 4 types of algebraic expressions that you need to know to factorize. We will have to memorize some of these. We need to split this objective in 2 parts, as I said before. Part 1, we will deal with these 3 up here. 1, 2, 3. And then in part 2, we will deal with this one down here. So let's begin part 1. What does it mean to factorize algebraic expressions? Now recall when we were dealing with number theory, we considered factors of a number. Example, in the case of 30, the prime factors are 2, 3. Let's refresh your memory from previous video. This was part 3 of objective 1.1. That's the very first section, when we were talking about factors and multiples. Now let's see that last division there. If we take 30 and we continuously divide it by the smallest prime number and then the next smaller one and so on, you notice that we get 2, 3, and 5. So the prime factors of 30 are 2, 3, and 5. We did that same thing for 70, and we find that the prime factors are 2, 5, and 7. If we multiply the prime factors of a number, we will get back that original number. Example, the prime factors of 30 are 2, 3, and 5. If we multiply 2 by 3 by 5, we will get back 30. In a similar way, to factorize an algebraic expression is to find, generally, 2 other expressions, which when multiplied, will give back the original expression. So what does it mean to factorize algebraic expressions? To factorize an algebraic expression is to find any, generally 2, other expressions which when multiplied will give back the original expression. So if you are going to factorize a squared minus b squared, we want to find 2 factors which when multiplied would give you that. And that applies to all 3 of them. So let's consider some very simple examples to begin with. Factorize 2y. Well, obviously, if you multiply 2 by y, you will get back 2y. So if you were to factorize 2y, this is what it would look like. 2 multiplied by y. Now that is extremely simple. How about if you were to factorize 2y plus 4? In this case, we want to find the HCF, the highest common factor, in 2y as well as 4. We can extract 2 from that, and if we do that, we are left with y plus 2. So if you multiply 2 and y plus 2, you will get back 2y plus 4. So the answer to this is 2 multiplied by y plus 2. Those are the 2 factors, 2 and y plus 2. All right, let's step this up a little. Factorize 2y cubed minus 4y squared. Are there anything common in both of these terms? Well, to help you see that clearer, we will expand them. 2y cubed is 2 multiplied by y multiplied by y multiplied by y. And then that minus there is this minus. And 4y squared, 4 is 2 times 2, and y squared is y times y. Do we have anything common in those 2 terms? Well, yes, we have 2 here and 2 there. We also have a y here and a y there. And we have another y here and another y here. So what can we extract? We can extract 2 and y squared. So one factor is 2y squared. We can take that out from both of those terms. So what does that leave us with? If we take 2y squared from each term, what we are left in the first term with is y by itself, that's this y, minus 2. So y minus 2 will be the other factor. So what are the two factors? 2y squared and y minus 2. So if you were to factorize this expression up here, what you will get is 2y squared, open bracket, y minus 2, close bracket. Those are the two factors. We can verify our answer. If we expand this, will we get back what we began with? Yes, 2y cubed minus 4y squared, which is exactly what we began with. Okay, one more prerequisite like this before we move on to the types required by CSEC. Factorize 2y minus 6x plus 9x cubed minus 6y squared. Now first, we will rearrange terms with the same base so they are near to each other. So we take that negative 6y squared and bring it close to that 2y. And that leaves the 6x and the 9x. Now we regroup if needed, as I just did, and then we find the HCF per group, the highest common factor. Let me expand this so we could see what is happening. This 2y is this, minus 6, that's 2 times 3, y squared, minus 6x, that's 2 times 3 times x, plus 9x cubed. Well, 9 is 3 by 3, and this is x cubed. So let's look in the y and then the x and see if we have anything common. For y, we have 2 here and 2 there. We also have a y here and a y there. And so for y, the factors we have are 2y. We could extract 2y from there. And what remains is 1 over here and 3y over here with a minus. So 2y, open bracket, 1 minus 3y, close bracket. Those are the two factors from the first term with the y's. Let's look at the x. We can get a 3 here and a 3 there. We can get an x there and an x there. And that's about it. So what can we extract? Now be careful here. We can extract a 3x, and that will leave us with 2, that's this 2, plus a 3x squared. But you need to be very careful with these signs here. So this plus here actually becomes a minus, because once you expand this, you want to make sure that you get back the original. So please take note of that negative there, as well as this minus sign here. And so what we get is 2y multiplied by 1 minus 3y, that's the first part, minus 3x multiplied by 2 minus 3x squared. So this is the answer to that. We can verify our answer by expanding this. If you expand this and then you expand that, what do you get? You get 2y minus 6y squared. That is 2y minus 6y squared minus 6x plus 9x cubed minus 6x plus 9x cubed. Now let's do some reverse engineering here. We're going to start with what we know, get an answer, and then reverse to see if we will get back what we began with. If we take a plus b and we expand it, that is really a plus b squared. Let's identify the second bracket by using different colors. So a plus b multiplied by a plus b. We will multiply each term of the first bracket with all the terms of the second bracket. So we get a, that's this a, multiplied by everything there, a plus b. And then we multiply b by everything there, which is this term. And there is a plus here. If we do that, we get a squared, that's this, plus ab, plus ba, plus b squared. We can combine those two terms in the middle there. And what do we get? We get a squared plus 2ab plus b squared. So what we are really trying to get at is if you are given this term, a squared plus 2ab plus b squared, you need to recognize that as a plus b squared. So a plus b squared is equal to a squared plus 2ab plus b squared. If you see this pattern anywhere, you can factorize it to that. But you have to remember that. Or if you are asked to factorize this, your answer will be a plus b squared. Anytime you see this type of. So we have looked at this part of the requirement of the syllabus, the plus part. A plus b and a plus b. Now let's deal with a minus b and a minus b. That is really a minus b squared. If we expand this, what do we get? We get a squared minus ab minus ba plus b squared. We can combine those two and we get a squared minus 2ab plus b squared. So a minus b squared will give us a squared minus 2ab plus b squared. It is a pattern that we need to learn. If you see a pattern like this, a squared minus 2ab plus b squared, you have to factorize that. It is a minus b squared. So we have looked now at this part, the minus part. Not so long ago, we looked at the plus part. So if you are asked to factorize anything that looks like that, straight off, you know it is a minus b squared. Now let's look at this example. A plus b multiplied by a minus b. Previously, both of them were plus and both of them were minus. Now one is plus and one is minus. Let's expand that and see what we get. You have a minus ab here and a plus ab here. So you know what will happen with this. That part will become 0. So you are left with a squared minus b squared. So if you ever see an expression that says a squared minus b squared, and you need to factorize that, it is a plus b multiplied by a minus b. And this is what you get when you expand it. So we have just looked at this part here. A plus b multiplied by a minus b. Those are the factors if you have to factorize this expression, a squared minus b squared. So if asked to factorize a squared minus b squared, you will know straight off that it is a plus b multiplied by a minus b. Now keep in mind that the expression a squared minus b squared, there is an understood 0 ab in the middle, but that is not so stated. Remember I said this part here works out to be 0, but we can ignore that. Now back to the syllabus types of expressions. A squared minus b squared. Recall that these are integers, and it says a, b, and c are integers. A is not 0. So we are looking at this first requirement here. Factorize a squared minus b squared, example 1. We want two expressions, both with a and b, which, when multiplied, will give us a squared minus b squared. Let's do some brainstorming. We will try some possible combinations with a and b. If you use a plus b and a plus b, notice we will get positive b squared. So this expression cannot be one of them. If you use this combination here, now you will get negative a squared, and we want a positive a squared. If you use this combination, you will get a positive a squared and a negative b squared. So maybe that will work. And if you use this combination, you will also get an a squared, positive, and negative b squared. So maybe this will work as well. Now, the thing about it is this one in the middle here, you will hardly see that in any textbook, but it is correct. This is the one that you are required to know. So we will learn that one. As I said, this one is correct, but normally you wouldn't see that. What you will see is this one. So we will stick with this one. A squared minus b squared. So now let's apply that. Factorize 4 squared minus 3 squared. Remember, the 4 will be a, and the 3 will be b. So if we factorize that, it is 4 plus 3 multiplied by 4 minus 3. Remember this here. And so we can use that, a squared minus b squared. If we substitute up there, we will get 7 here. And if we work it this way, we will also get 7. So a plus b multiplied by a minus b. So you find the sum multiplied by the difference. That's what it really is. Another example, 6 squared minus 4 squared. The sum multiplied by the difference. Now, if you work it out up here, you will get 20. And if you work it this way down here, the sum multiplied by the difference, you still get 20. So the answer here, if you have to factorize this, 4 squared minus 3 squared, it is 4 plus 3 multiplied by 4 minus 3. Example 2. If we have to factorize that, keep in mind that this is a and that is b. If we substitute those numbers, we will get 7 here. But if we use this rule, it is a plus b multiplied by a minus b. We add those two numbers, a and b, and we multiply it by their difference. And we get 1 multiplied by negative 7, and we still get the same 7. So if you have to factorize this, this is what you get. Example 3. Factorize negative 4 squared minus negative 3 squared. Remember, that is a and that is b. So we set it up in this format. Negative 4 plus b and negative 4 minus b. And this is what we get when we factorize that. Now you may say, this looks more difficult than this one up here, but we are factorizing. We get 7 up there, And down here, if we add that and multiply by their difference, add them, you get -7, multiply by the difference, -1. You also get +7, like you got up here. Now, that was the first type. Let's go to the second type now. A squared plus or minus 2ab plus b squared. So we finished with that one. Let's look at this one. Remember, there are two versions of this, the one with the plus and the one with the minus. So if you have to factorize a squared plus 2ab plus b squared, we need to remember that we want two expressions, both with a and b, which when multiplied will give back this. Let's do some brainstorming. We will try some possible combinations of a and b, a plus b and a plus b. If we do that, we will actually get back this. But if you take -a and -b and you square that, you will also get back this answer up here. This combination will not work because you have a -b here, and that one will not work because you have a -a squared here and a -b squared there, and so on. So it has to be one out of these two, this one or that one. As I said, normally you wouldn't see this one in your textbook. Mostly you will see that one. So we will stick with that one. So if you see a squared plus 2ab plus b squared and you want to factorize it straight off, you should know that it is a plus b multiplied by a plus b. You will always get that. This one will work too, but don't use this since most people don't use it. This one will not work, and this one will not work. So look at that plus there. It seems that both of these will do. Both of these will do, but we will choose the one that is normally used, which is a plus b squared, which is that. So if you ever have to factorize something that looks like this, a squared plus 2ab plus b squared, you know straight off that it is a plus b squared. Now, let's deal with the one with the minus instead of plus. A squared minus 2ab plus b squared. Now, will this work if we brainstorm? Yes. Will this one work? Yes. Will this one work? No, because you have a minus b squared here, and we want a plus b squared. Will this one work? No, for two reasons. You have a minus b squared there, and you have a minus a squared here. That's not what we want. So, one out of these two here, that or that. As I said, this one is not normally used, so we will stay away from that. We will use this one. A minus b squared. So again, while both of those can be used, we will use this one because that is the most commonly used one. So if we see anything like this, a squared minus 2ab plus b squared, we know it is a minus b squared. That's how you factorize it. You have to memorize this. And if you see anything like this, a squared plus 2ab plus b squared, then it is a plus b squared. That will take care of this. And we already dealt with that one. So example 4, factorize 3 squared plus 2 times 3 times 5 plus 5 squared. Except you may see this one in the middle here as 30. Then you have to break it down to this. Now we will take it to the format into a plus b squared, because you really have, if that is a, and this is a, and that is b, and that is b, you have a 2 here. So that is really a squared plus 2ab plus b squared. So this whole thing becomes 3 plus 5 squared, that is a plus b squared. And if you work that out, you get 64. But you need to recognize that this is A and that is B, and that is 2AB. Let's look at this example. Factorize 4 squared plus 48 plus 6 squared. Now we will try to get that into this format. We know A is 4 and B is 6. So that is A and that is B. But the middle term, 2AB, is that equal to 48? If so, we can use A plus B squared. This 48 here, that 48 there. Is it 2 times 4 times 6? And yes, it is. So in essence, this 48 becomes 2AB. And so we have that format, A plus B squared. So 4 plus 6 squared. You don't have to work it out, but if you do work it out, you get 100. Because we were told to factorize it. So if you factorize that, we get this. 4 plus 6 squared. Factorize 6 squared minus 36 plus 3 squared. Now, you see this minus here? It is not a plus, right? So we need, if that is A and that is B, we need to express this as a minus 2 times A, B. So we know A is 6. We know B is 3. That's the first and last term. But is the middle term 2 times A times B? Can we get negative 36 from that? No, but it could be if we make that 3 negative 3. Now we can use A minus B squared. 6 squared minus 36 plus 3 squared. This 36 here is 2 times 6 times negative 3. And so we have, instead of plus here, if we multiply that negative twice, we will get positive here. So it's A times 2AB times B squared. So it is 6 minus 3 squared. So if you see an expression like A squared minus 2AB plus B squared, this is how it will be factorized. Often, this type is used as a stepping stone to type 4 that we will do in the next video. Factorize x squared plus 6x plus 9. So we have an A squared here, we have a B squared there, and in the middle here, because that is plus, we need a 2AB. Note the first term is x, the last term is 9, which is 3 times 3. The middle term is 2 times x times 3. So A plus B can be used. Example 7, factorize this. That's the same example we had up here. So this is A, that is B, this is the 2, and that is AB. So x squared plus 6x plus 9, we can factorize it as this, x plus 3 squared. Example 8, factorize 4 squared plus 24 plus 3 squared. Notice this plus here and this plus here. So it must be that 4 plus that 3 squared. This 24 here, we will take a closer look at that. A plus B and A plus B. It is A plus B squared. So this 24 here is 2 times A, which is 4, times B, which is 3. That 24 is 2AB. 2 4 is 8, 3 is 24. So we can take a number of guesses, and then we find that A plus B squared can be used as the whole expression is in the format A squared plus 2AB plus B squared. Now, so example 8, if you want to factorize this, 4 squared plus 24 plus 3 squared, because all of these are plus, and you could see a 2 times 4 times 3 there, then it is 4 plus 3 squared. You don't have to work it out like that. This is factorizing that expression up there. Now we come to this last type here. Factorize ax plus bx plus ay plus by. This is not as difficult as the one we just did. We will separate terms with the same base. So this is x, and that is x, that is y, and that is y. Factorize each group. So we can get an x out of here, and that would leave us with a plus b. And we can get a y out of here, and that will leave us with a plus b. Now factorize the whole expression. There is an a plus b here, and there's an a plus b there, so we will take that out. A plus b, and what are we left with? X plus y. And so, if you had to factorize this expression, this is your answer. A plus b multiplied by x plus y. We can conclude that if a is the same for one x and y, and b is the same for the other x and y, then this is what happens. Ax plus bx plus ay plus by is equal to a plus b multiplied by x plus y. So we are still here. Factorize 2x plus 3x plus 2y plus 3y. We see that we can clearly get a 2 and a 3 here and here and here and there. So we extract the 2 and the 3. That would be one term. And that leaves us with x one time and y one time. And of course, we could reduce that a little further. 3 plus 2 is 5 times x plus y. So if you had to factorize that, this is what you will get. Let's try one more like this. Factorize 7x minus 3x plus 7y minus 3y. Notice this 7 and this 7, this 3 and this 3. So we could extract 7 minus 3. And what remains? An x. Now, I know it looks like 2x, but we will list it as 1. And a y. So 7 minus 3 multiplied by x plus y. And that would give us 4 times x plus y. So if you had to factorize that, this is the answer. Example 12, factorize negative 7x minus 3x minus 7y minus 3y. Again, note that 7 there and this 3 here. So you could easily extract negative 7 minus 3, and what remains is x plus y. Note this plus here, because you may think it should have been minus, but if you keep a minus here, when you expand this, you will not get back that. So that's negative 11 times x plus y. So if you had to factorize this, this is what you will get. So up to this point, we did that, and that. If you see something like a squared minus b squared, that came from a plus b multiplied by a minus b. And if you see something like a squared plus 2ab plus b squared, that came from a plus b squared. Or a squared minus 2ab plus b squared, that came from this. And finally, this one down here, a plus b multiplied by x plus y. And that brings us to the end of part 1 of objective 14. Next, we will deal with the most difficult part of this objective, which is this one, ax squared plus bx plus c. That is in the next video. So we looked at objective 14, part 1, factorize algebraic expressions. We looked at these 3 that CSEC wants us to know about. And that brings us to the end of video 14 based on objective 14 in section 6.